Hey everyone, so today we have somebody joining in from India. You solved 900 LeetCode questions?
Yeah, and this is my second mock with you.
Nice. Okay, this is your second mock. So how many or what questions did I ask you last time?
It was like a merge emails, and
Oh, okay.
one was easy. I don't remember the question name.
Yeah. Were you able to solve the questions?
Yeah, means I was not able to implement the DSU fully.
Oh yeah.
The
Okay.
time ran
Yeah, I
out.
remember you. I remember you. Yeah, you did pretty
Yeah.
good. Okay, let me think.
Yes.
I actually come okay. Let me look through my when did you join into the stream? Have you been into in the stream for a long time or no?
Just before the last guy.
Okay. So you just saw the last guy? Okay.
Yes.
Let me get into the first question then.
Okay.
So in this question, we're going to be given an undirected tree consisting of n vertices. Each there are going to be some vertices with some apples. You need to tell me the amount of time it takes to collect all the apples, right? And walking over an edge takes 1 second. And you start at the vertex zero, and you eventually have to come all the way back to the vertex zero. So I'll post in one example, and then you could whiteboard it to tell me to see how it works. I think it'll make sense if you whiteboard it a little bit, but
Okay. So there are seven apples, right? N is equal to seven means seven apples
or seven nodes.
of the tree. Yeah. So I am on the whiteboard. Yeah. So I'm thinking of first making a tree. I don't know, it is not working.
Oh, why? Just try refreshing, or hold up, click seven.
Okay, okay, yeah, makes sense. Okay, so these are the edges. 1, 4, 5, to the left, 3, and 6. So yeah, s- so this is the edges are undirected, and edges I by AI BI means that exists an edge connecting the vertices AI and BI. Additionally, there is a Boolean array has apple, where has apple I is equal to true means the vertex I has an apple, otherwise it does not have an apple. Okay,
Yep,
so here 0, 1, 2 has an apple,
yep.
and 3 and 4 has an apple. So and 5 also have an apple. So yes, these three only have an apple. So I am trying to figure out how, means how the answer is coming 8. So if we start from 0, if we go one down, then one down. For collecting 4, we have to go two places down, right? And for collecting 5 also, we have to go two places down. For collecting 2, we have to go only one places down, so it is 5. And I think we have to return back also, return the minimum time in seconds you have to spend to collect and coming back to this vertex. So from 4, it will take 2 units of time to come back, and from 5 also it will take 2, and from 2 it will take 1. So basically, no, but when we reach point 1, it will take only 1 unit of time to reach back.
Yep.
So if they are same siblings, then we have to only reach the parent and we can minimize the time, right?
Mm-hmm.
So means, firstly I was thinking that it would be just the double the time to reach. Means whenever we reach the apple, every time we count, and if we double the time, but that really is not the case here, because if we double the time, the answer will come as 10, but we are minimizing the time when we reach. Means while going back from 4 to 1 and from 5 to 1, we will count it both as 1 second, right? And from 1 to 0, we will not count 2 seconds, we will only count 1 second. Is
Sorry,
that
could you repeat that?
so? When we are at node 4,
Yep.
while going back to 0, while going back to 1, we will count it 1, and from 5, while going back to 1, we will count 1, right?
Sure.
But from going back from 1 to 0, will we count 2 or just 1?
Well, okay. Why is this answer 8?
So for this to be answer 8, from 0 to 4, it is taking 2 seconds for me to reach 4, and for 0 to 5, it's again taking me 2 seconds to reach 5. From 0 to 2, it is taking 1 second for me to reach 2. So this comes out to be 5. Now I have to return back to my original starting node, which is 0. So from 4 to 0, it is taking 2 units. From 5 to 0, it is taking 2. And from 2 to 0, it is taking 1. Right? Or I am missing something here.
Well, that doesn't add up to 8. What you just said there.
Right. And that is coming to be 10. Yes. So from whenever we are reaching 1, so I am thinking that whenever I am reaching 1, I will collect all the apples in the left subtree, and then I will collect all the apples in the right subtree. So it will take me lesser time. So from 0 to 4, it will take 2 units. From 0 to 5, it will take 2 units. But while returning, I will just return from 5 to 1 and 1 to 0. So it will take 2 units only. So total will be 6 here. And while going to 2, I will go one step forward and one step backward, right?
Yep.
So it is taking 8. Okay.
Yep.
So now I understand. So while going while going in a side, we will have to take all the apples in that path and return back to the parent and go to the other side and take all the apples and then return back to the parent and to the starting node. So yeah, so firstly I think I can create a graph rather than tree. So if I go through all the, means I can create a graph where O means 0 will always be the starting point, right? Yes. Okay. So and then I can run DFS and find, means if the has apple is true, means if the has apple for that node is coming as true, then I will add 2 to the answer and move forward, because 2 units will be taken to take that apple and return back to the parent node. Make sense?
Mm-hmm.
Am I missing something here? I am just looking for that part. So from 0, if I run the DFS, firstly I will come to 1, then has apple is false, then I will go to 4, then has apple is 1 here, then I will return back and I will make the resultant as 2, because 2 units of time has been taken for me to go to 4 and return back to 1. Then I will go to the right of 1, and if 5 has apple, then I will return 2 back to 1, and then I will move back with 2 plus 2, the left and right summation.
Mm-hmm.
And I think that makes sense.
Okay. So this is gonna return 4.
So means if the so m- means if the child of the parent contains an apple, that parent will also return 2, right? Because we are taking 2 units of time to come to that parent and traverse back to the node. Okay, so the parent should also return 2, so it should return 6, then 2 plus 2 plus 2, 6. And here, if I go to the right side, I will go to 3, means I'll go to 2, and it will return back 2. No, I will go to 3, it is false. I will go to 6, it is false. But parent is true. So means if the parent, if while sending up, if the resultant value contains a value or the has apple node is true, I think we have to return resultant plus 2 while moving backwards.
Mm-hmm.
So yeah, that's what I think. So can I go ahead and start implementing?
Yeah. Go ahead.
Okay. So here I define minimum time I will take in. The input will be n edges and has apple. So I am first trying to make a tree from the edges, or a graph, whatever we call it. For node, comma. So it is an undirected graph, so I am appending both the directions. So now I think I have to define. the DFS I can define. I am doing the first search with node and parent. So whenever the means firstly I need a resultant which is equal to 0. So I will go in neighbors of all the nodes. So for neighbor entry of node, so if neighbor is not is equal to parent, I have to check it is not equal to parent. So my result will become the DFS of neighbor comma node. The parent will be node. And while going back, if if the child means if res is present or has apple of node, then I will return back res plus 2 and return DFS of 0 comma minus 1. Means I think this is gonna work.
Okay, res add if res or okay. Well, let's. Can you walk me through line by line?
Yes. Firstly, I have created a tree. Then I it is an undirected graph, so I have appended both the node and the neighbor to the tree in 23 and 24. Then I have defined a DFS function. In DFS function, I have firstly defined the result, my result to be 0, because from starting the result is 0. Then I traverse to the neighbors of the graph, which is 1 and 2 for 0.
Yep.
And if neighbor is not is equal to parent, I am checking that if it is not already visited, means if it is not the parent of means 0, 1 would be connected to 4, 5 and 0,
Yep.
and the parent would be 0. So
Yep.
I don't want to go back to 0 again. So resultant would be my the DFS of 1, whatever 1 is throwing. And if I so firstly I start with 0, the neighbor would be 1, then I go back again, and then it would reach 4. When I reach 4, if result, so here the result will be 0 at first because we haven't, but we find the apple at 4, so we will just return back 2.
Yep.
So here I am just checking if result, because whenever a child is returning back a parent, uh, whenever a child is containing apple and it is returning back to
Yep.
the parent, it should also the parent should also take 2 units of time to return back to its parent. So that's why I keep on adding 2 if whenever the resultant has a
Yeah.
value.
No, it makes sense. Let's run it on this test case.
Okay.
Do you think it's gonna work on the first go?
Yes.
I see.
Yes, I think. Let's see.
10.
So it is returning 10. Okay. So Why is it returning 10? Let me go through once. So, firstly, if I go to um, drying, dry running my code. So, firstly, if I go to 0, then it will go to 1, then it will go to 4, and 4 will return back 2, and then it will go to 5, and 5 will also return back 2, rest plus 2. So I think it will come always, it will always come additional of plus 2, because I am at last, whenever I am getting an answer, I am doing a rest plus 2. So I think it would be like a df answer would be minus 2. And I think whenever there is no apple, I can return 0 and max of both. Yeah, now I think.
Nice.
So because I am thinking this, because when it comes to 2,
Yeah.
uh, whenever it comes to my position where it is having the last apple and my resultant is showing the answer, it is again doing result plus 2 at the last, which is not actually required, the last iteration. So every time I think now it can work. Can you have, do you have any other example for this so that we can try? It will
No,
definitely work for this.
yeah, I think that works. I think you're fine. Let's move on to the next question.
Okay.
Sorry. Yeah, let me
So
grab it.
right, because we are doing DFS and going through
Yeah.
each of the node once.
Yeah, what's your time and space complexity?
Yeah. For space complexity, it would be the number of nodes in the tree in the worst case. For means in the worst case, it would be the height of the tree, exactly the space complexity in the stack we are storing in the DFS which we are doing. And for the tree which we are, means the tree which we are storing, it will be order of number of nodes and number of edges, the maximum of number of nodes and number of edges, the space complexity, because in the tree we are storing the undirected graph. And for the time complexity, we are only running DFS, so we are only going through the tree once. So it is order of number of nodes.
Okay, sounds good. All right, I'm gonna ask you the second question.
Okay.
Good job.
So I did this in like 25 minutes, I guess.
Like 20? Oh shoot.
Yeah.
Pretty
So
good. Yeah.
I'm preparing for Google, so I need to be fast as.
Yeah. Okay.
Yeah.
Now this is the second question. You're given two strings S1 and S2. Find out if they only differ by the insertion of a phrase.
Okay.
When's your Google interviews?
It's scheduled for after 2 months. I have time.
Oh, you're gonna pass it easily.
No, means last time I wasn't able to. So yeah, let me go through this question. So if I'm given two strings and I have to find out if they only differ by the insertion phase. So example one is the boy goes to hospital. The cute little boy goes to hospital. Cute little is the added phase. Everything else is the same. So return true. Okay. Is nice. The girl is nice. Return false.
Wait,
Okay.
so in Google, are they gonna ask you two questions in the span of 40 minutes? Is that how it works?
Right. Exactly. Yeah.
Okay. And are you interviewing for Google India or Google US?
Google India currently.
Okay, nice. Yeah, chat's asking some questions. Okay, go ahead.
Yeah. So means it is the problem of H1B visa nowadays.
Yeah,
You must have heard.
yeah,
Yeah.
I've seen that.
So the boy goes to the hospital. The cute little boy goes to the hospital. The cute little is the added face. Everything else is the same. So return true. And for example, two, the boy is nice. Okay. So I'm thinking that if in the above case, if I change the boy to girl, it will be false, right?
In the above case, you put, yeah, it wouldn't work no more.
So means every in a string one, every means every word should be a part of string two. This is my first assumption I am thinking. So every word in S1 should be a part of S2 and means the order should also matter here, right? Means suppose I am taking one example here at the bottom. So control X. So this would be means this is not a place, but this should also return, right? Because the ordering is incorrect.
Wait, right here, the boy goes to.
64, 65.
Yeah,
Yeah, means
yeah. That
the
that that one shouldn't work.
okay. So maybe I think I can go here. I can split the words and go pointer by pointer. And whenever I find a mismatch, I can go via left pointer and right pointer. And whenever I find a mismatch, I try to move the left pointer and try to move the right pointer.
What do you mean? Try to move the left pointer and try to move the right pointer.
Okay.
That's vague.
Yes, yes. Yeah. Okay. Let me go through this example and collect my thoughts. So here would be my pointer, and here would be my second pointer. So if the here and in the second string,
Yeah,
so
four pointers.
if the word is not matching, I will directly return a false.
Okay,
Then here the and the both are matching. I move this to the second value, and here I move this again to the second value.
sure.
And these both does not match. I move, I come to the right pointer, and if these both are matching, I move both backwards, and again. The and the is matching. I move again backwards. Then 2 and 2 are matching, and I move again backwards. And my first point means my left pointer should match with the right pointer. If both matches, there is an extra phase in the second pointer in the second sentence. But if both does not matches, the left and right pointer does not point to the same word at the end, that means there is more than an extra phase.
Wait, so
So here
you're gonna
goes
move
and
up. So you have like two pointers at the front. Whenever they get a mismatch, you're gonna start moving the pointers from the back.
right. And means if both the left and right pointer in the smaller string matches, means both the left
Yo,
and right
Mod, what's
pointer in
up?
the smaller string, for example in 64, if I remove the goes here, so firstly I will move the left pointer, which is the, if there isn't a mismatch, I will move it to boy and the second pointer moves to cute, right? And then there is a mismatch, I move the right pointer backwards. And after 2, when the right pointer points to boy in the first string and the second pointer points to little, so both the left and right pointer points to the same boy, so means so I can derive that there is only an additional phase because the left pointer is already matching to a point where we are currently at the left side and the right has reached that side. So
So this side, this would return true or false?
this would return false,
Okay.
because means the, after I go here, means whenever, firstly my the matches, and when I move the left pointer to boy it does not match, so I move the left pointer back one way to back to the, because the is the only thing matching. So if I go back to the right pointer, right hospital, the and 2 will match, and when I come to boy it won't match to the bottom string.
Yeah.
So the left and right pointer are both not pointing to the same words currently, so it will return false. If I remove the boy, okay, and my right pointer will point to the, and the is where the left pointer is currently and the right pointer, so I think that will return true.
Okay. Sure. All right. Go ahead and implement.
Okay. So means I am firstly moving. Will the string 1 will be always of the smaller size, or it can differ?
It can differ.
Okay. So here, if length of S1, if S1 is larger, I will move S1 to the second. So here I am doing the basic that every time S2 will be larger. I'm just swapping it, and then I am splitting it. I need to split it via gap. So there is one more case which is coming to my mind. If there are two gaps in between,
Two gaps.
yes. So
Well,
means that will return true or false.
what do you
So
think
suppose
based on the problem statement? What do you think?
if they only differ by the insertion of a phase, means by based on the problem statement, I think it won't matter that much, and it will still return true if there is an additional space here in line 50 and
Oh,
51,
you're
if
saying
I
an
am
additional space.
right,
Oh,
right.
yeah, yeah. We could have just assumed that it's a proper sentence with proper spacing.
Okay, okay, makes sense. So so I'm comparing the left pointers first. String 1 of left 1 and string 2 of left 2 both are equal. Then I will just left 1 plus is equal to 1 and left 2 plus is equal to 2. Sorry, plus 1. And I will move the back pointer also. At the same time, I can move. I don't need to. A string of right 1 is equal to string of right 2. So it would be minus 1. So here, if I go, the and the will match. Left and the right will point to 1 and 1, and it won't match. So left one and the right one would be strangled to 1. Both will end up here in 1. Going back to the right pointers. So right one hospital and hospital, the 2, and it will be 1.
Like, you're did you change up your
Yes.
approach? Now you're moving both the pointers at the same time.
Yes, means I think it won't make sense to move the pointer whenever there is a mismatch. We can move both the pointers at the same time.
Okay.
Yes.
Yeah.
So right 2 will point to, it will point to 0, and it will point to, so if left of 1 minus 1 is equal to right of 1 anytime. Sorry, it will go, it will go till 0 only. For 0 then 1, yeah, then okay, means I, the will match, left will point to 1, and left 2 will also point to 1. Boy and girl won't match, both is pointing to 1 here, 1 and 1. And for right one,
If left
boy,
one minus one equals right one, return true.
so here if string 1 of right 1 and right 2 nice is matching, then is matching, and then boy and girl is not matching, both will end up at 1 comma 1. And yeah, means I think this should work.
Try running it on some the test cases.
Okay,
Well, I don't get
let's,
your final conditions there. Like, could you explain line 87 to 89?
okay, line 87, every time, means whenever the loops gets over, every time my left would point to the position where there is the first mismatch index.
If the
Make
left
sense?
I minus one equals right I. Okay.
So every time my left one will point to the first mismatch index.
Okay. So
And
basically,
if,
this loop is gonna stop increment or stop move like the left will stop moving in whenever it's not equal anymore, and the right will stop moving in when it's not equal anymore. So if the I mean let's run
okay,
it on
yeah,
an
yeah,
example. Yeah. Like
yeah, the left one and right one. If left one is less than the right one, the loop will stop. So every time the right one crosses the left one. Oh, yes, the loop condition should be changed. So whenever I can just make it true, loop is running if left one, then no. If left one is less than right one. So if left the both will point to one, and both, worst case, No, this loop won't work. You are right here. And means every time it is true, if left one and left two is matching, I will just keep on incrementing. If right one and right two is matching, I will just keep uh, if string of string one of left one not is equal to string two of left two means else I can just break out of the loop I am thinking, but that won't work here too. If string whenever both are matching, I just move the pointers
Yeah.
back and making sure both are moving. I just need to think of a place where the loop will stop. The loop will stop whenever the left one is, yeah, that was correct only, I think.
Well,
Less than a, yeah,
there's an infinite loop there. What if these pointer like what if those don't match at all? If left one is not equal to left two, right one doesn't equal to right two, then it just
right.
nothing ever, like the point it will never, left one will always be less than right one. But
Yes,
yeah.
yeah, yeah, makes sense. Yeah. So,
Okay, we're pretty much at time, but maybe I'll give you 2 extra minutes.
okay.
Try
So,
try to finish it off strong.
yeah. So, I am thinking that if both the conditions are false, then I'll just break out of the loop. Yes, I think
Elif string.
I don't think means will it work? I'm not sure about this.
Yeah, I'm not sure. Okay, since we're pretty much at time, let's just
Yeah.
go through feedback. How do you think you did?
Yes.
How was that?
Means the first question was I think I did it nicely, but the second question was a basic but a tricky one. The ones Google asks every time. So I think I need to work on the basics once, I guess.
Yeah, this one's a. I think you. What might work if you just do this like else
Else
false,
break. Else false. Yeah.
like return that something like that, and then maybe just like return true. Would that work? Maybe something
Yes.
like that. Maybe.
So
I think, yeah. Or Alpha saying that wouldn't work if the string. I think that would work because we have left one and left two. Those need to increment.
yeah, means
Right, they
you
might be
can
off
run
by one, but
right.
like another solution to this is pretty much one would be you just have two pointers, right? Starting from the
Right.
left and the right, or start, yeah, one at the top and one at the bottom, and when they have a mismatch, move the pointer on the longer one up by like the difference between the two arrays, because then you just need to match like the latter
Right,
part.
right.
But
Yeah, that's a nice solution. Yeah. Now I'm thinking about it. Yeah.
I think for
That's a
this, you would have you would have been able to solve all the edge cases if you were to dry run the code or like work through a small solution with the like try to dry run the code and see where it would break. Because I think you're trying to fix it and Google doesn't let you run the code. So if you're trying to fix it by just thinking through it, it's gonna take forever. So yeah, it's just dry run the code. I think you could have got it to a stage where you could just dry run the code, and then you would have seen where it went wrong, and then just fix it. But yeah, I think you did really good on the first question. I thought you were gonna do really good on the second question. You were doing pretty good. You wrote down your assumptions. You were logically working towards a solution. I really liked your solution actually, with starting with the two pointers on each end on both and moving it in. But just the implementation, you just couldn't get to
yeah.
it. So
Yeah. So what will be the verdict this time?
I
It
don't
would be
even know.
part.
It's like definitely not a fail because you did good on the first question. I think it would just be like it would still be a higher but not a strong higher. I think
Right.
I wouldn't really dock you hard because you're just you had the right solution but your just implementation was just like 95% of the way there. But like you don't want to leave it up to chance. You want to make sure that especially when you already had the solution, just make sure that you get the code written down.
Yes.
But yeah. All right. You should schedule another one soon. These are fun. These are pretty good.
Yeah, I will definitely schedule another one.
All
Yeah,
right.
but I am thinking that it would be better if it is of system design. I am
Oh yeah.
preparing for all, so
Yeah, we'll do system design. All right, man.
and
I'll have to hop to the
what?
next person, but or what were you gonna ask?
Yeah, yeah. Means I just wanted to ask, where does Alpha works?
Alpha works at a unicorn company. Or no, it's public company.
Okay,
Yeah.
okay. Means he is
He's
a
pretty
nice
good.
coder. Yeah, yeah. I always see his comments while others are coding, and I find it pretty interesting.
Yeah.
Yeah, okay. I
All
will
right.
hop on
Yeah,
the
we'll see.
stream.
We'll see. We'll do a system design next. I'll coordinate something and we'll see how you do. Good luck.
Yeah,
All right.
yeah.
See ya.
Thank you so much.
No problem.
Yeah.
Bye.